Good morning, this is Sancho McBrien, student at the Center for Cybersecurity and Mathematical Cryptology with student number UBA25 EP107. We were given a task to create an Etherskill security architecture upgrade. Recently, our transition to distributed hybrid cloud exposed a critical vulnerability, the reliance on shared root passwords. Today, we are securing our infrastructure by moving from shared secret model to principle of least privilege. Here's how we executed using Kali Linux. Firstly, we created a centralized authentication by tackling identity management, managing local passwords across multiple machines. It's a security risk waiting to happen. To solve this, we'll deploy a free IPA on Kali server. Free IPA acts as our central source of truth, bundling LDAP, cables, and DNS. Once the Kali directory is established, we install a free IPA client using our Ubuntu database node and join to the domain. Now all user authentication is routed through a single auditable system. No more local accounts, no more shared root. With our identity centralized, we need to enforce what those identities can easily do on the database. We use the vsudo command to configure strict role-based policies and define two specific commands aliases: the junior developers group, which is granted with only access strictly to the system logs, allowing them to troubleshoot without touching critical infrastructure, and the senior ops group, which is granted permission to restart, start, and stop the system services. By explicitly defining commands, we ensure users have exactly the permissions they need to work and absolutely nothing more. Next was the SSH management, where we eliminate the risk of password leaks and compromised laptops. Passwords are no longer an acceptable method for server access. Every developer is required to generate a secure ED25519 SSH key pair. Once their public keys are distributed to the servers, we edit the SSH daemon configuration on both Kali and the database nodes. We explicitly disable the password authentication and permit root login. From this point forward, access requires a cryptographic key. If a password is stolen, it is useless. Finally, we lock down the network layer. Our database production is currently exposed to the entire internal subnet. We are fixing this using NFT tables. We configure a strict firewall rule set on the database with a default drop policy. We allow basic SSH access, but we write a highly specific rule for the port 3306, the MySQL database port. We configure NFT tables to accept traffic on this port only if the source IP matches our Kali application server. Any other machine attempting to query the database is immediately blocked. By implementing free IPA, strict sudo rules, SSH enforcement, and targeted NFT tables rules, Etherskill's infrastructure is now hardened, auditable, and resilient. The days of shared root are officially behind us. This project was carried out on Kali, and since Kali does not have the exact rules that CentOS would have used, we had to create other rules. Thank you for watching this video as it goes to the end.